All right, today we're going to talk about analyzing tables and graphs, and this is a completely new unit for you guys. We're going to be talking about a couple of important things called constant of proportionality, constant rate of change, things that you probably haven't heard but maybe have heard of before. The words that you're going to need are the word constant. Constant means something that goes at a consistent rate. So that is, we're looking for straight lines that go that way, up and down, this way, this way. We're looking for things that go at a constant rate. Things that are not constant are lines that look like that, or a line that looks kind of jagged like that. That's what we mean by constant or non-constant. And as we go through this lesson, there are several pieces that you're going to need to keep up with. Everything goes together. If you miss one piece, you're going to miss the entire unit. So you need to make sure that you're keeping up, pay attention to the vocabulary. It's a pretty simple concept because a lot of it is just reading and looking at a graph and taking information and putting it on a graph, or taking it off of a graph and putting it into a table. It's all about understanding what the pieces are. So there's not a ton of math involved, but there's a little bit of math, but the majority of it is paying attention and understanding what the pieces mean. Once you get the pieces, this should be pretty simple and easy for you. We're going to talk about things that are proportionals, which we've been talking about for the last several months in regards to, if I spend $2, I get 2 apples. If I spend $1, I could get 2 candy bars, things that are constant, finding that rate of change. We're just taking that to another level to create lines and graphs. So I'm going to jump right into what this constant rate of change means. And so here's a couple of new things for you. You've never seen this little symbol before, or maybe you have seen that little symbol. Mathematicians used to use the Greek alphabet, or they do use the Greek alphabet for quite a bit of their things that they that are brought into what we use today. And it's from all their scientific experiments and their mathematical experiments and their trial and errors and their things. And they have a Greek alphabet that they used to show symbols rather than writing words, so they could get more on a page, or they could get the information out there faster, or maybe their handwriting was horrible and writing the words just did not look right, but they could do the shapes. So in the Greek alphabet, this symbol is called the delta symbol, which means change. So anytime you see this little symbol, this little triangle symbol, it means change. I'm going to find the difference of something minus something. What is happening? The change. What's happening between the two numbers? So between the number 1 and the number 2, the change, we are adding 1. So the difference between 2 and 1 is 1, because we are changing by adding 1 each time. Or in this case, not 3. If I'm going from 2 to 1, I'm changing by 1. So I'm taking the difference. You're taking the two numbers and subtracting the two numbers to figure out what your change is. That's all that means. And then we're going to use it in a fraction or a proportion or a ratio, because all of them mean the exact same thing, or the division problem, a change in y over the change in x, which you'll start to see here in just a few minutes what I mean by that. So up until now, we started working on something before the break where you took some coordinates, you put them on a graph, and it created a picture. So I gave you these coordinates like 3, 4, and you had a graph, and you went over 3, and you went up 4, and you put your dot. And that was your coordinate. So here's your coordinate. Here's where you put it on the graph. Now what we're going to be doing is we're going to be creating lines with those. So we're going to be extending those and connecting those to create lines from equations. It's the exact same thing that you've been doing. We're not going to change anything. This is still x and this is still y. You still put it on the graph the exact same way. You still call it the exact same thing. you just have to remember that this number is X and this number is Y. All right. We're going to talk about what makes a line proportional, and what that means is that it crosses through 0, 0. So a simple way to look at that, and you're going to get more information as we go, but there's your graph. Here's your graph. This is 0, 0 right there. If I were to draw a line based on the coordinates that I was given, that line goes right through the center. The center is called the origin. And if the line goes directly through the center, that means that it's proportional. If that line let's say that line crosses right here, that is not proportional. So kind of like exactly what I told you a minute ago, it's all about reading the graph and understanding what it means. There's not a ton of math involved. If you look at this graph and it goes right through the middle, then it's proportional. If you look at the graph and it doesn't go through the middle, it's not proportional. Not proportional. Not proportional. Not proportional. 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 I think you guys get the idea. So if it crosses through the middle, it's proportional. Okay, and the last vocabulary word, linear, it just means that it's a line. It's whenever I put points on a graph and it makes a straight line. 0, 1, 0, 0, 2, 0, 3. Probably not the best line. Let me give you a better line here because I'm making this up as I go. So 1, 1, 2, 2, 3, 3. So what that means is I go over 1, up 1, over 2. Actually, I'm going to go up 3. Let me just redo this line. Okay, we'll get rid of that. Oh my gosh. If I were to graph those, I'd go over 1, up 2. There's the first one. Over 2, up 3. There's the second one. Over 3, up 4. That's what that means, is that they just connect to make a straight line. That's all it means. Okay, so let's start digging into what all of this means and how you need to know it and how it works. And this is where I've expressed and I've really stressed to you guys that you have to know your multiplication facts in order to understand how numbers work. So this is where it's going to come in handy, because this is where the math part is just a basic math part for this concept. If you don't know your multiplication facts, that's going to really hurt you in figuring out what you're going to need to do. The rest of it is just looking at the graph and understanding how it works. So make sure you know your multiplication facts. Make sure you use your multiplication charts if you have it. Sometimes it's going to be trial and error. You're just going to have to, it's going to take you a while to figure it out. That's why it's important to know your multiplication facts. So you're going to be given a table, and this table has a series of numbers, and those series of numbers either represent a value that goes on the x-axis or a value that goes on the y-axis. And so the first thing that I would suggest that anybody does, and on these notes, you don't have a graph to graph it on, but watch what I'm doing here. I'm going to go ahead and just make up a graph. There's 0, we'll make that 10, 20, 30, 40. And notice how I went up by every 2 lines. So that means that this line is 5. This line is 15. And so there's numbers in between those numbers. People, whenever you have a graph, I could do each one of these as 10, but then my graph would be so large, and I'm going to be just spending hours on creating a big graph. So you will see graphs where you'll have to interpret, okay, what is each line increasing by? So in this case, it's increasing by 5s. Why is it not erasing? So anyway, that's why I did it like that. This is my x-axis. The x-axis is always on the horizon, and it is always first. Then you've got your y-axis. I'm going to go up by, these values are going up by 6s. I mean by 10s. So let's just go ahead and just write that 6, 16, but let's skip one. So that's 6, skip 1, 16, skip 1, 26, skip 1, 36. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Okay, so what I've done is I've taken this graph or this table and I've just created a graph. I'm going to go ahead and put those points on the graph. So all this means is 10, 6, 20, 16, 30, 26, and 40, 36. These are my x values and those are my y values. Those are my coordinates. I just put it in a graph that's going long ways instead of up and down like you're used to seeing, but it's the same exact thing. So let's plot that. 10, 6, 20, 16, 30, 26, 40, 36. And as you can see, I could connect those and I get a straight line. So I have graphed this line. Now, what do we do with that? What we're trying to find is, what is the constant rate of change? What is happening constantly? So the way that we figure that out is we take what's called the change in x, the change in y, over the change in x. So what that tells you to do is what is happening with the numbers in the y's. So look at that first. The y always goes on top. On your graph, x's go first, but when you're trying to find the change of something, the y goes on top. So you'll need to write this every single time to help you remember. So, because if you bring it up to me and I don't see the change, I don't see this, I'm gonna ask you to go back and figure that out. So let's start with the change in the top number, which is the change in y. So what's happening with the y's from 6 to 16, from 6 to 26, and 6 to 36. Okay, this one's easy to see. But if you don't know, you're going to take the change, two of those numbers. So 16 minus 6. Well, that's increasing by 10. Then you have 26 and 16. That's changing by 10. And 36 minus 26 is changing by 10. So that is what your change is, and that's the number that you need for your change in y. is 10. Now, do not assume that when you do the first numbers that it's changing by 10 for everybody else. In this case, it does. You have to check all the numbers because there may be a number thrown in there that proves that this is not an actual true line. So you need to make sure that all of these are the same value. Okay, so we've done the change in the change in y. Now it's time to do the change in x. Well, 20 minus 10 is 10, and 30 minus 20 is 10, and 40 minus 30 is 10. So the change in x is also 10. So the constant rate of change in this line is that it is change in y over the change in x, which equals 10 over 10, which simplifies to 1. So your rate of change is 1. Now, a while ago I told you what the word proportional meant. Proportional means that this line happens to go through 0, 0. Well, how do you know that it goes through 0, 0? Well, I drew this green line here, and it shows that, oh, it's going through 0, 0. But what if Mr. Faber didn't really draw right? What if it doesn't look right? Or what if I'm not a perfect artist, which I'm not? You look at your graph that you've been given, or your table that you've been given, and go backwards. So this is, the top is increasing by 10. And so if it was still continuing to increase by 10, this number would be 0. So 10 plus 10 is 10, or 10 minus 10 is 0. If I do the same with the y's are also changing by 10. So if I were to complete this, that's what plus 10 equals 6, which is negative 4. So if I were to graph this one more point that Mr. Fabro gave us, so -0, -4, if I were to graph that, I would start here and I would go down by 4. And this will be my next plot, which when you look at this, you're increasing by tens, and you get -4. And when you graph that, this line right here actually does this. So it doesn't go through 0, 0. The next point on this line that just erased the whole thing. I'm just going to mark it out like this. Actually goes from here to here. So it does not cross at the 0. So this line is not proportional. So just to recap, you're plotting your numbers. So you put your coordinates on your graph. Once you figure that out, you find out what the change in y is, which we did by subtracting the two numbers. Then we did the same thing with the x, and we got 1 as our constant rate of change. And then to find out whether it was proportional or not, we had to continue our rate of change for x and y to find these two numbers, which told us that it didn't cross through 0, 0. So this line is not proportional. We'll do another quick example here. And I'll try to go a little bit faster. Okay, first things first. put my x's and my y's. Oops. So 0, 0, 1, 4, 2, 8, 3, 12. Now I know on your paper you don't have little graphs like this. I would suggest that you draw graphs as you do your assignments, because if you draw the graph, it's easier for you to see whether or not it goes through 0, 0. If you draw it, plot the points. You don't have to, but it's so much easier to see, and then there's not really any math involved. Okay. All right, so let's go plot these points. So we've got our 0, this is our x-axis, and this is our y-axis. These top numbers or the x's are going by ones. I'm gonna skip so that way you can see a little bit better. So I have skips, so every one is half. And then going up, I'm gonna go up by 4, 8, 12. So this number right here is 2, 4, 6, 8, 10, 12. Something I probably shouldn't have to teach you. Okay, let's go ahead and graph that. 0, 0. Go 1 to 4, 2 to 8, 3 to 12. And I don't know why I wrote 4, because we don't need 4. All right. All of my points, there was a 0, 0. So I automatically know that this is proportional because it does go through 0, 0. Let's find my change in y over my change in x. Remember, the change in y is this. So going from 0 to 4, I'm adding 4, I'm adding 4, I'm adding 4, oops, adding 4. So my change in y is 4. My change in x, 0 to 1, I'm adding 1. 1 plus 1 is 2, plus 1 is 3. So my x is 1. So my rate of change is 4 divided by 1, which is 4. So my constant rate of change is 4. Make sure you're writing the change in y over the change in x. Be consistent and write it each time so that way you know it. And so this one is done. The one thing that I did forget to talk to you about is the function rule. This is where you need to know your multiplication facts. So that function rule tells you, if I were to put a value in x, what do I need? What will it take me to get the y value? So what the heck does that even mean? So I'm going to scroll this up just a little bit. So my function value, if I take whatever the number is in the x, what am I going to get? How can I get to the y value? So in this case, my x to y is, I would take the y value, sorry, the function rule. Let me just write this like this. Not what to, what operation gets me from x to y. What that means is, if I take x, what am I going to need to do to that value to give me y? Well, in this case, 0 to 0, well, 0 plus 0 is 0. 0 minus 0 is 0. 0 times 0 is 0, and 0 divided by 0 is 0. So I can use any of the operations. So I need to go to the second one. What from 1 can I do to get to 4? Well, 1 plus 3 So 1 plus 3. So my x plus a number should give me what my y value is. Well, 1 plus 3 is 4. Okay, so let's try that in each one. So x plus 3 should give me the y. So on the second one, 2 to 8, 2 plus 3 does not give me 8. It gives me 5. So my function value, I can't add 3 each time. It's got to be the same for each one. So we got to go back to the drawing board and do it again. This is why it's important to know your math facts, because if you look at this, all you're doing is multiplying each x by 4. So x plus, sorry, whoops. Come on. So basically what I'm saying is every time I get my x and I go x times 4, 4x, I should get my y value. So my x is 0. And if I take 4 times 0, I get 0. And if I take 1, so 1 times 4, I'm going to get 4. If I take the 2, 2 times 4, that's going to give me 8. So my function value, and 3 times 4 is going to give me 12. So my function value is 4x. I know it's a long way to explain it, but what you're trying to find is what's happening between x and y each time to get those numbers. And I'll show you a better way to find the function value here in just a second. All right, let's go to the next one. Okay. This time I gave you the table, and I gave you a table up and down. So it's already kind of pre-done for you. So let's just take that and let's graph it. Okay, we know that this is 0. The x's are going by a weird number. So let's just do them by twos. 2, 4, 6, 8, 10. And the y's are going up by another weird number. You can actually just look at this from the very beginning and see, okay, well, first of all, can this even be a line? If I were to go plot those numbers, I'm going to have to draw a graph that looks like this. And so we know the first one, negative 10 and positive 5 is going to be there. Then we have negative 6 and positive 3. Then we have negative 2 and positive 1. Then we have 2 and negative 1. It kind of looks like a line, but if you were to actually set the graph aside and do it, it is not a line. So the way you're going to work this out, oh God, I hate this, is that you're going to find the constant rate of change, so the change in y over the change in x. So what's happening with the y's? 5 to 3, you're subtracting 2. 3 minus 1, you're 3 minus 2, you get 1. And 1 minus 2, or 1 minus a negative 1, you're subtracting 2 each time. So 5 minus 3 is 2. 3 minus 1 is 2. 1 minus a negative 1 is 2. So all of them are decreasing by 2. So you've got a constant rate of change in your y's. It's subtracting by 2's. On your x's, this is negative 10 to negative 6. So how do I get from negative 10 to negative 6? So negative 10 plus x equals negative 6 minus 10 on both sides. Oops, I'm not doing that right. Negative 10 to get to negative 6, I'm adding 4. Oh my god. I'm so sorry, guys. You're adding 4. Negative 6 to negative 2, you're adding 4. Negative 2 to negative 2, you're adding 4. Oh, guys, I skipped to the last one on accident. I'm sorry. I'm sorry. Okay, so this is creating a change in y over change in x. So you get your change in y and you get your change in x. They're both constant. They're both increasing the same amount on each side. So when you simplify this, you get 1/2. So negative 1/2. So your rate of change is negative 1/2. So it goes by 1/2. What's happening with your function is every time I take negative, if I take your x and I divide it by negative 2, I'm going to get your y. So in this case, negative 10 divided by negative 2 is positive 5. Negative 6 divided by negative 2 is positive 3. Negative 2 divided by negative 2 is positive 1. So your function rule is x over negative 2. That's why you have to know your multiplication facts. I can't reteach you how to do that. You need to be able to visually see, how do I get from this number to that number? And then lastly, we got to find out if it's proportional. Proportional means, does it go through 0, 0? So if we were to graph this on a graph, we would find out that yes, it does go through 0, 0. How can we find that out without putting it on a graph? We can look at this and we can go, these are subtracting by 2's. There are numbers in between. So what is the number between 1 and negative 1? That number is 0. And if that number is 0, and if I subtract by the same number there on the y-axis and the same number on the x-axis, that tells me that it is proportional. We're going to do lots of practice with that, so don't get too stressed about it. Okay, let's go back to that first one, that function rule. That function rule on the very first one, and maybe this will help you understand what it looks like. To find your function rule, make a table, put your x's, 0, 10, 20, 30, and 40. And my y is negative 4, 6, 16, 26, and 36. So how do I get from there to there? The exact same way in the whole thing. Well, for each time, I'm taking the x value and I'm subtracting it by 4. So if I take the x, which is 0, and I subtract 4, I get negative 4. If I take 10 and I subtract 4, I get 6. 20 minus 4, 16. 30 minus 4 is 26. And 40 minus 4 is 36. So this is the part that's going to take you the longest if you're not familiar and you can't look at the numbers and see what's happening. That's why we've harped so much on basic addition, basic subtraction, multiplication, and division. All right. That last one somehow disappeared. So I'll rewrite it here. So this is the third one. So go back to the third one. You've got an X and you've got a Y. 4, 5, 7, and 9. 8, 9, 11, and 15. And the function rule, the constant rate of change, and if it's proportional. Okay. This is where you got to pay attention. Change in y over the change in x. Let's look at this table. If I were to look at this table and I were to put if I were to put it on a number line, there are numbers between here. There's 4 to 5, and then the number between 5 and 7 is 6, and then between 7 and 9 is 8. Okay. Over here, between 8 and 9, there's no numbers. Between 9 and 11, there's a number. And between 11 and 15, there's 12, 13, 14. So right here, you can tell that there's not going to be a constant rate of change. So from 8 to 9, we are adding 1. From 9 to 11, we are adding 2. From 11 to 15, we're adding 3. So if you look at that, okay, well, that kind of looks constant every time it's going up by a new number. But remember, constant means that it's got to be the exact same. So this side does not go up the exact same. Let's look at the other side. The other side, it's increasing by 1, then it's increasing by 2, then it's increasing by 3. Well, you could tell yourself that, okay, well, both sides are going up in numerical order, so it's a constant rate of change. But remember, all of these numbers, these all have to be the same. And since they're not the same, it's not a line. So if I were to put that on a graph, I'd go over to 4, 8, 5, 9, 7, 11, and you can already tell that my line's going to go like that. So that's why I think it's a good idea if you draw a graph, because you can immediately say, hey, look, this isn't a straight line. There's no function rule. There's no constant rate of change. And since it's not a line, it can't be proportional. So there's some overview of how this works. It should help you on the assignment. If you've got questions and you need any help, let me know. Send me an email or whatever, and I'll help you out. Otherwise, this should help you.